On May 11, 1964, Canada quietly entered an elite group of countries capable of designing, building, and operating unmanned aircraft. Montreal-based Canadair created a series of fast and stealthy surveillance drones called the CL-89 and CL-289. It was a high-tech endeavor that showed off their ingenuity at the height of the Cold War. The story of the CL-89 and CL-289 started in the early 1950s with the creation of Canadair's Missile and Systems Division. The group worked on advanced missile projects like the CL-20 Velvet Glove and the CL-54 Sparrow II, both of which were cancelled before they became operational. For more information about these projects, check out my video about the evolution of aerial weapon systems. Canadair wanted to maintain expertise in the field of unmanned aerial vehicles in the wake of these cancellations. To this end, they began working on a series of projects such as the CL-36 target drone, which was a high-performance remote-controlled target for missile testing, the CL-85 robot dispatch carriers, which was designed to carry 4.5 kilograms of supplies on a short-range ballistic trajectory, and the CL-87 Army Logistics Missile System, which was a larger and guided version of the CL-85. These systems never went into production, but their work helped shape future projects. In 1959, market research led Canadair to commit itself to create a fast, mobile, low-flying, low-visibility, short-range, unmanned aerial surveillance platform for use by the Canadian Army. The system was designed to provide commanders in forward battle areas with near real-time tactical intelligence. A typical mission would go something like this. It was designed to be carried and launched on a truck-mounted rail. Before launch, the airframe and cameras are prepared and checked. It is fueled and the expendable wings and directional control fins are installed. A booster rocket and stabilizer fins are attached. The sustainer turbojet is spun up and checked. Once up to speed, the launch rail is raised to the optimum angle, and when everything is ready and the crew is clear, the booster rocket is ignited to propel it up to its flight speed. The booster rocket falls away once the propellant burns out and the craft begins to automatically navigate through a series of waypoints. These waypoints can be programmed to avoid air defenses and penetrate areas too dangerous for manned aircraft. Pictures are taken by a high-resolution camera at predetermined points along the flight plan. After completing the mission, the vehicle then returns home and is given a landing command from a ground-based transmitter. A parachute is deployed and airbags are inflated as it descends to the ground. Once recovered, the camera's film is taken to an interpretation facility where it is processed. The drone is then sent to be refurbished for another mission. Initially, the unsolicited project was privately funded by Canadair. Due to its secret nature, they broke with their traditional naming system and initially called it the XC-1. Design work and refinements continued for another year and a half. By 1961, Canadair had settled on the details of the design and proceeded to build a full-scale all-metal mock-up to test and fit the various systems it would carry. In June of 1963, the governments of Canada and the United Kingdom decided to cooperatively fund the development and testing of the aircraft, which was renamed the CL-89 in keeping with Canadair's project designations. The 156-kilogram CL-89 was 2.6 meters long and 33 centimeters wide, 94 centimeters including the wings. A 113-centimeter-long booster rocket produced by Bristol Aerospace of Winnipeg, Manitoba, provides 22.3 kilonewtons of thrust to bring it up to its final flight speed of 740 kilometers per hour. Once the booster drops away, a Williams Research WR2-6 turbojet sustainer engine producing 0.56 kilonewtons of thrust takes over. The small turbojet could operate on jet fuels like JP4 and JP5, or it could use standard diesel if necessary. Its surveillance equipment consisted of a tri-lens Carl Zeiss 70mm camera that could shoot day or night. The film could easily be removed by a technician once the drone had landed for developing an interpretation. The goal was to have target data available to artillery batteries no more than 30 minutes after the drone was over the target. In November 1963, the Canadian National Defence Department revealed details of the agreement. Canada would purchase 3 Oberon-class conventional diesel-electric submarines from Britain in exchange for their commitment to invest in the CL-89's development costs. The U.S. Army also agreed to provide firing range facilities at the Yuma Proving Grounds in Arizona and support for future flight test programs. The first flight was attempted at YPG in March 1964, but failed due to the launcher not being at the correct angle when the booster was ignited. The first successful flight was on May 11, 1964. The drone flew the planned 44.3-kilometer course in 4 minutes and landed within 1.6 kilometers of its intended landing site via the aid of a homing beacon. More test flights were carried out at YPG in 1966 and 1967. In November 1967, the testing was moved to CFB Shiloh in Manitoba, where it was tested under simulated combat conditions. It was at this time that the West German government began to take interest. In December 1967, the Canadian Department of Defense Procurement announced that the United Kingdom and the Federal Republic of Germany were partnered on an advanced order of the drones, NATO designation AN/USD 501, valued at approximately $40 million. In 1970, German and British personnel began training with the new platforms at CFB Shiloh. The British Army renamed their CL-89s the Midge, and it began operational service in 1971. It entered operational service with the German Army in 1972. In 1974, Italy began training on the CL-89 in anticipation of Meteor SPA co-producing a number of them for the Italian Ministry of Defense. The last country to buy the 89 was France. They ordered 6 units in 1980, and the system was operational a few years later. NATO became interested in the CL-89 as a target drone to simulate cruise missile attacks on warships. A few flight tests were carried out off the coast of Sardinia in 1971, but the plan was dropped when the reusability of airframes was called into question. By the time production ended in 1983, Canadair had supplied over 500 drones to Britain, West Germany, France, and Italy. The 89 turned out to be more rugged than expected. The airframes had a life expectancy of 10 flights, but some flew as many as 40 flights before retiring. The British Army used the CL-89 for the first and only time in combat during the 1991 Gulf War. It made around 70 flights over enemy lines with outstanding results. It was determined after the war that the newer systems intended to replace the 89 and the surveillance drone, such as the Phoenix and the Pioneer, were inferior to it in many ways, such as reliability and image resolution. The 89, after all, had a sensor suite that rivaled some of the manned platforms. After a long operational history, the drone was retired from the German Army. The airframes and launch equipment remaining in German service were transferred to the Turkish Army, where they continued to serve. Although the airframes had been retired, the need for unmanned surveillance had not, and the replacement system was necessary. This had not gone unnoticed by the people at Canadair. Starting back in 1977, the CL-227 Sentinel surveillance drone was designed with a different set of goals. Unlike the 89, it was meant to be able to operate from the decks of ships at sea. As such, it was a VTOL UAV with minimal visual radar or infrared signatures and a long endurance. It incorporated many interesting design features, including directing the engine exhaust upwards to help hide its infrared signature. The peanut-shaped Phase 1 prototype made its first flight on the 25th of August 1978, and it was fairly successful. The larger production Phase 2 vehicle first flew untethered on December 14, 1981. Testing continued, and following an evaluation by NATO in March 1982, it was made available to NATO allied clients. However, no sales were forthcoming and the program was closed. What would truly replace the CL-89 was laid down in the early 1970s after a meeting between Canadair and Dornier GmbH of Germany. Originally thought of as a CL-89 Mark II, the program quickly evolved into a completely new system incorporating greater range, more surveillance equipment, and a fully digital flight computer. While the airframes looked similar, they shared no common parts and required a complete redesign of the launch equipment. The new design was called the CL-289. It was designed to meet a German Army requirement for a Corps-level unmanned intermediate-range reconnaissance drone. The overall mission plan would be the same as the CL-89, with the addition of a new quasi-terrain following mode, allowing for increased survivability and capability. The 289 would be capable of approaching the target at low altitude to avoid radar detection, and then pop up to gather intelligence before dropping back down to low levels for its escape. In July 1976, Canadair was awarded the contract to develop and manufacture a prototype CL-289. In January 1977, testing of an all-metal scale model at the National Research Council's high-speed wind tunnel in Ottawa had begun. By March, they had proceeded into drop testing of the airbags and recovery systems. France's Société Anonyme de Télécommunications joined the program in March 1977. 3 years before they would field the older CL-89 system. They contributed an infrared line scan system with real-time data uplink and a ground-based tracking radar used in the testing phase. In August 1978, Dornier successfully tested the booster dart tails with the full-scale CL-289 mock-ups to study their separation characteristics. Unlike the CL-89 and CL-227, which used Williams research engines, the CL-289 was to have a German-built turbojet. The Klockner-Humboldt-Deutz T117 engine produced 1.07 kilonewtons of sustained thrust, twice that of the Williams WR2-6, and it was ready for installation and testing by January of 1979. The first flight-worthy CL-289 drone was completed on April 17, 1979, and photographs were shown to the public for the first time. It was longer and heavier than its predecessor, having a length of 3.52 meters, a width of 0.38 meters, and a wingspan of 1.32 meters. Unfortunately, a lot of the details surrounding the CL-289 are still classified, and so its launch weight, range, and flight speed are unknown to the public. However, the flight speed is rumored to be around 730 kilometers per hour. It is known to have carried an infrared line scan system and a Carl Zeiss KBR-824D tri-lens day or night camera. The infrared line scan data was recorded on board, but it could be relayed to field commanders in real time using a data uplink. The Zeiss camera had to be recovered and processed on the ground, just as it was with the CL-89. Flight testing of the new drone was carried out at the vast Yuma test range. While Canada did have an instrumented test range at the time, it was too small to cover the drone's intermediate range. The tests proved that the quasi-terrain following mode worked and would keep the CL-289 out of harm's way. While these tests were largely successful, there were a number of crashes and accidents. Some were due to the improper handling of the equipment, others were due to computer software problems, and the rest simply crashed into the desert. The joint Canadian, German, and French test program showed that the 289 was a potent reconnaissance platform by mid-1983. On the 24th of January 1986, Germany, France, and Canada signed a deal for the pre-production phase of the program. Finally, in November of 1987, a contract worth $410 million was signed for the delivery of 250 289s for the armies of France and Germany. It was the largest ever defense export order up to that time for Canadair. Although the airframes would be built in Canada by Canadair, the Canadian government wasn't interested in operating it. Germany began flying production 289s starting in January 1990, and their complete system was up and running by 1992. France followed with a series of tests starting in November 1991 and concluding in January 1992, after which it entered formal service. The French renamed their 289s the Pavers. Italy joined the club in 2002 when they bought 20 289s and one launcher. This was a significant upgrade from the CL-89s they used to operate, but they were seen as a stopgap measure until a more advanced drone could be sourced. Most of the details surrounding the deployment of the CL-289, whose NATO designation is AN-USD 502, are still secret to the public. What is known is that the German army conducted reconnaissance overflights of Serbia and Kosovo during the 1999 NATO Operation Ally Force campaign. At least 3 of their 18 289s were shot down in one mid-April week during missions to support the campaign. They decided to suspend these costly missions after their third loss and the wreckage of one airframe being displayed on Serbian television. The French Bavars are known to have operated in the Middle East Gulf region in 1993. They also flew their Pavars starting in January 1996 during the Bosnian conflict for NATO's Implementation Force, also known as IFOR. One airframe was lost, but the cause is unclear. They served again in Afghanistan from 2002 to 2003 and in Chad in 2008. Canadair's Surveillance System Division began looking into possible successors to the 289 starting in the early 1990s. This improved drone, called the CL-389, would incorporate new avionics, new data recording systems, new navigation systems, a radar altimeter, a tactical GPS unit, a videotape recorder, and an Identify Friend or Foe or IFF unit. Unfortunately, there wasn't any interest in such a craft, and so the 389 was cancelled during the pen and paper stage. In 2003, an upgrade program for existing 289 airframes was put into effect. It was called the Aulos 289 and featured a GPS unit, new software, and other improvements. Germany upgraded 100 and France upgraded 56 of their 289s to the Aulos standard. The program is meant to extend the life of the drones comfortably into the 2010s. The Canadair CL-89 and CL-289 were a tremendous achievement for the Canadian aerospace industry. While the Canadian military never operated the systems, they were well loved and respected by the British, German, French, Italians, and Turks who flew them. They proved that Canada was capable of designing and building unmanned aerial systems, a feat few other countries could claim.